All right, so today we have a very special guest, and it's a great pleasure to welcome Michael. I would like to start by acknowledging the country. Those of us at the University of Queensland are coming to you from, this land is Mianjin, and we pay deep respects to all elders, past, present and emerging on this land and the lands from which we are presenting. This is a language technologies course, and it's a real pleasure to acknowledge the Turrbal and Yagara languages of this land. So today I particularly am pleased to welcome Michael Running Wolf. I know of Michael's work from several workshops and his international profile, but in particular from a workshop at Murips last year. So Michael Running Wolf is North Cheyenne, Lakota and Blackfeet. He was raised in a rural prairie village in Montana with intermittent water and electricity. And naturally, he now has a master's of computer science. He's a published poet, he's a computer nerd. He was raised with a grandmother who spoke his tribal language, Cheyenne. So by leveraging his advanced degree and technical skills, Michael hopes to strengthen the ecology of thought represented by minority languages. In his spare time, Michael pursues Indigenous language and culture reclamation using immersive technologies, so augmented reality, virtual reality, XR, as well as artificial intelligence, and building an automatic speech recognition system for an Indigenous language from the Pacific Northwest. So it's a great privilege to have Michael speak to us on Indigenous AI today. Michael, over to you.
Thank you for that. Do I have share? Cool. Okay, so I am going to kind of, give me a second here, I'm trying to orient my screen. Okay, here we go. Here. And so, can you guys all see my screen?
Yes.
Okay,
Yes.
okay. Yeah, so I am Native American from North America, and I am a member of the stereotypical feather Indian, so to speak. I am Lakota, Blackfeet, as you mentioned, and also a part British princess. So I really like Earl Grey. I grew up, my parents are really into tea as well. And so I grew up here in my native plains habitat, so to speak, our cultural area. And this is a picture of my wife's tribal gathering. She's Abzalaga or Crow, and they have like the biggest teepee camp in the world, or in North America for sure, at the Crow Fair here, you can see. So this is who I am. Like, this is what I grew up on. This may not be so different from a lot of Australia. I mean, I've never been there yet, but I've seen pictures and it seems kind of dry. It's also similar to where I grew up. And so I live in an arid area. And as you see here, can you guys see my mouse, I assume?
Yes, we can. Yeah.
Yeah. So if you think of North America, there's this huge continent, and this continental United States of America. I grew up here, this little area here in the southwestern part of Montana. And culturally in North America, you can pretty much summarize like the patterns based upon rainfall. This is actually a, if you look here, our ecology that I grew up in was the high plains, this whole area here, and this is more like the riverlands. So when you think of like American breadbasket, that's really, they're talking about this huge area here along the Mississippi and the Missouri and the Mississippi rivers. And of course, over here in California, there's a lot of green spots there. I grew up here. And so we were hunting primarily. We spent culturally, my tribes, the Lakota, Blackfeet, and Cheyenne, they're all plains tribes. The Blackfeet are from over here in the north parts of Montana, crisscrossing into Canada. And Lakota, their territory was from the Great Lakes all the way over to the Rocky Mountains. And the Cheyenne, we're a smaller tribe. I think there's like 10,000 of us today. That's probably how much there were ever. And so my mother is Cheyenne, and I grew up on her reservation. And so in Montana specifically, we have one of the highest I think technically Montana's not a very big tribe, a big state. There's about 1 million people in all of Montana, and we make up probably 8% of the population, which is quite large relative to. So it's one of the largest percentage-wise population. So we make up, and we have like 7 large reservations, basically internment camps historically. And you have Northern Cheyenne, Crow, Fort Belknap, Fort Peck, Rocky Boy, and these are the Blackfeet, the Cree, the Dakota, and the Gros-Ventre, which are a type of Algonquin, somewhat related linguistically to the Northern Cheyenne. And the Salish and the Kootenai. The Kootenai are isolated language. There's not very many related languages. The Kootenai and the Salish are the inland Salish, so they're related to the coastal Salish. And of course, you have the Crow. They hate this designation, but their language is very related to the Siouans, which is Lakota, Mandan, Hidatsa. They have an entirely different theory, but I guess it's a different question for a different time. And we, the Cheyenne, we're Algonquin. Like I mentioned earlier, there's the Gros-Ventre. We're linguistically similar to the Cree in the Algonquin family. There's the Cree. There's us, the Cheyenne. There's the Arapaho, and so on and so forth. And so we're really a rich and diverse linguistic heritage within within Montana. And of course, Blackfeet. I think the largest language other than English spoken is Crow. They've been pretty good at maintaining their linguistic heritage. I think like when I was a kid, I think 80% of the children spoke Crow. It's been dipping, unfortunately, due to the typical causes of colonization. And so this is the environment in which I grew up in, me and my wife. And so because of this cultural heritage loss, for example, the Cheyenne, we have 500 fluent speakers. The Crow have several, I think over 10,000 plus speakers, the Blackfeet similarly. But we're all in the same boat, right? Regardless of how many speakers you have, we are approaching a generational gap and a generational loss, because the speakers are predominantly older generation in their 60s and 70s, and with COVID most recently, it's highlighted this problem where we don't have enough speakers. The speakers that do exist are quite literally dying off, and so our languages are at risk, regardless of how many speakers you have, simply because a lot of our speakers are older. And when you speak to the people in the communities that we worked with, me and my wife, the main question was why? Like, why aren't we speak to the elders and like, why do you think that the language is endangered on the Blackfeet or the Cheyenne or the Crow? And the typical response from the elders was, the kids are distracted by technology. And so we got inspired by that. This was like a while ago, maybe 10 years ago. And so around 10 years ago, it's been, VR started to come on. This is my dad putting on a headset. It's like one of the very first Oculus headsets. And this is where like I was working with, I had a grant from Facebook or Oculus at the time, and they gave us a headset. So we were building like cultural experiences. And you can see these 2 little girls here. And this was in Missoula, Montana, and we were doing an exhibition of AR, and there's something about XR, VR, AR, where it completely engages the user. Like these 2 girls didn't know each other, a little Blackfeet girl, a little white girl, and they both just sort of naturally started in this interaction. And I will always show this picture every time I talk about this, because this was so magical how these 2 girls were able to interact with AR and teach each other, and they just got it. Like this at the fundamental level, because it's very physical. AR is different than the phone, because with the phone, you get there and you have to scroll, and all these like skeuomorphism paradigms. Whereas in AR, you just are in reality. And so our goal has always been to create XR technology in combination with AI to build linguistic kind of conservational experiences. And so, but unfortunately, the AR, there's a few problems. Number one, there's not a lot of content out there. Like this is something we scanned. Let's see here. So this is a alk hide scraper. So when you're building XR technology, you need 3D assets. And one of the problems is that a lot of our heritage, our physical heritage, is not in indigenous lands. Like we wanted to talk about the elk scraper and its role in hunting. So all of the tribes that in my genetic heritage, they were buffalo hunters or bison hunters. And an implement of hunting the bison was also scraping and cleaning the hide. And this is one of those tools. But virtually all of them are outside of indigenous hands. They are in the hands of private collectors. And so me and my wife began by, so we want to build the XR experience. One of our early goals was to build about a buffalo hunt, but we needed to get the tools. But they just were not in people's hands. So we found a willing and generous collector who allowed us to scan their collection. And so this is using photogrammetry. We were very careful. These artifacts, I think this one in particular was at least 300 years old, potentially 3,000 years old, because these things lasted. It's made out of elk bone. And this is something that you would carry into your heritage. And until recently, these things were like family heirlooms. And unfortunately, they're also very valuable. There's a strong market for indigenous heritage in North America. And similar, I'm sure, in Australia, where art collectors and such. And so this kind of started this is the technology we used at the time. I don't think they exist anymore. Like all of this exists, but I don't think the product exists anymore. All of this momentum. This is a while ago. Let's see here. And some of the other work we did too, I just briefly scan through this, is that we did these projects for Oculus Launchpad. We did some projects we were at Standing Rock, and the last project we worked on in Montana was this Madison Buffalo Jump AR project. And so our goal has always been to build this technology that's not only advanced and interactive, but also community accessible. So I just love, it's unfortunate, but I just love the Google Cardboard devices, because everyone has a cell phone, and you just take your cell phone that you own and you plug it into the Google Cardboard, and all of a sudden you have a VR device. And they still work technically, but Google has discontinued the product. They no longer support it. It's open source technically, but no one's making the headsets anymore. So we have a box of 20 of these, which are rapidly becoming a kind of a priceless artifact. And this is so we're building these VR experiences. And the aesthetic I want to implement is that these things need to not be research oriented. Like I want technology that works and scales for the community level. I don't want the fastest, greatest computer to run the greatest, amazing doohickey, RTX ray tracing VR experience. I want something simple, cheap, and that you can deploy, that will work offline without internet. And the Google Cardboard, I thought was perfect. Unfortunately, history will show that the market just never really got into it. And so we started recently kind of along that idea of like, why don't we also use AI? And I think I need to set my audio, check computer sound. Sorry. So Janet, can you tell me if you can hear the audio?
Not hearing the sound, but we can see the video.
Okay, I'll just talk through it. There's nothing important going on here as far as the sound goes. So what it is I'll start from the beginning because I interrupted. So this is a project we worked on in 2019. I was working with Jason Lewis and Nalani Arista, who was in there, and they invited us to Hawaii to discuss that paper that you read actually was a product of what this situation here is. What we did is we took, what they did was they gathered 4 engineers into a room and said, write an essay. And know what we did? We wrote an application instead. We turned it basically into a 1-week-long hackathon. And we said, what can we do? Why do we actually build an indigenous AI application? And so we built Huaki'i, which roughly translates into like an image retriever. It's kind of in a way that it's cute in Hawaii. Like it's a turn of phrase that's meant to say it's like cute, and kind of nondescript, like a puppy or something. And so as we built this, what it is it recognizes 80 phrases, and they're the wrong 80 words is what they recognize. It's like in Hawaii, we discovered that it recognized, like we show her at the end, the user pointed the camera at a fire hydrant, but we realized that the fire hydrant just barely works. Like it was a weird fire hydrant. We went all over the neighborhood, maybe for like at least a kilometer or so, looking for a classical American boring fire hydrant, because in Hawaii it's actually kind of different. They have this weird, they look like a tube with a hat on top of it, versus in the video, it's kind of got this classic, dog pee in post kind of look. But they just didn't exist. The types of American fire hydrants that this AI was trained for was not in Hawaii. And so we had struggled to find a fire hydrant network and that would be recognized by the AI. And that's actually a problem for indigenous scenery, just in general. If you scale that everywhere, because these systems are built to work in San Francisco, California, or in Seattle, Washington, and I bet they probably won't really work very well in Australia, because everyone has different fire hydrants, so that you have this bias in the AI that's just intrinsic to how it's constructed. Because AI, when you build AI, you take a large training data set and you label it. Basically, you say this is a fire hydrant, this is a dog, whatever, and then you feed it into the system. But if your base data, hundreds of thousands of images that are labeled, is biased toward a certain person, basically a white male in San Francisco, then your AI is just not going to work for anywhere else. And that's definitely been shown. Like Siri and other voice AIs have trouble with second language learners. If you're learning English for the first time, often the AI just won't really work for you. And this is especially so for the indigenous people. So if you take this AI that's biased toward a certain person in San Francisco, and then you try to indigenize it, you run into a lot of problems. Like skiing is not a word that could conceptually even exist in Hawaii. There's just no word for it, and there was just like a bunch of useless stuff. And so this is kind of the problems as we're starting to think about building an AI for indigenous and AI, is that it's just fundamentally biased, not just against us, but against everyone. This is like a core endemic problem, and the reason why I was late is actually I was teaching AI ethics, specifically about AI ethics, to my AI class. I was teaching class, and I anticipated that the questions might go on longer than I anticipated, so I wanted to give myself a bit of a buffer. Unfortunately, I only came 20 minutes, but this is what I was talking about. Like, just when you bake in AI, the engineers often don't really care necessarily about the ramifications of how it's being built. So it's really important to start early. And so in my class, for example, I was just talking about AI, like teaching them what are the unintended consequences of the AI systems you're building, and really getting to think about that, because it's a real big problem. It's not something that can be solved with like more computing problem, processing power, or if you think more magically, it's just a fundamental problem with the artificial intelligence as a system. From end to end, the people who are building it are not ethicists. The goals in which they're accomplished are not necessarily good. They're profit driven, and these are all things, and they don't often take the community into account when they're building these systems. And so just fundamentally, the statement says the technology and AI is not built for indigenous people. And in a way, it's critically incompatible. And so it's important that we as technologists start changing that paradigm. And so what I've been working on, back to our world of language AI. So this is the raw data. I've been working on a project to take Wakashan languages, which are based in the Northwest. Let's go back here to the map. And so I'm in Vancouver, Canada, over here, and we're about like an hour and a half drive from the States. And right here is Vancouver Island. And surrounding the Vancouver Island and on the Vancouver Island in Washington State, in the United States and in Canada, is this language family called the Wakashan. and there are dozens of languages in the Wakashan language, and they are fortunately highly researched. Um, Famous Franz Boas, a famous one of the keystone anthropologists in the field of linguistics, studied Wakashan languages, specifically the Kwak-Wakiwak language, and or people that spoke the Kwak-Wakiwak and the Kwakiut and all that. And this is our raw data. It's analog, it's handwritten, and all of you are all language people. Has anyone actually worked with text language? Like, if I speak about orthography, did you guys even know what I'm talking about? Let me get a raise of hands if you thumbs up if you know what I'm.
So I think some will, some are more on the technology side and less on the language, and a few people are more on the language side and less on the tech. We've got quite a broad audience here.
Oh, awesome. Yeah, so I don't want to talk down to you, so I just kind of assume no knowledge. Not intended as a judgment of your intelligence. So the Kwak-Wakiwak have a orthography that has unfortunately changed even over the course of the lifetime of Franz Boas. Like when he first started studying the language, he started labeling phonemes a certain way. And then as he aged and continued his research into these languages, their orthography modified. And so we have this problem of competing orthographies within the same linguist, never mind other linguists who come, because it's sort of an inevitable situation. I've worked with enough languages in Montana with my own tribe, my wife's tribe, and Blackfeet languages. There's always, every linguist has their own orthography, their own opinion on the phonemes or the raw sounds of a language. So at individual, atomically level, the smallest sound is a phoneme. And conceptually, you have the next level up is like a morpheme, which is basically a concept, like car is a concept. So that would be a morpheme. And so, and this is unfortunately our raw data. And so we have like, his goal of us is to build Indigenous automatic speech recognition. And to do that, typically, I used to work for a large retail company, and we had a voice AI as one of our products. And we had millions and millions of books scanned as our corpus, our text corpus, our very large data set. And we also had millions and millions of recorded audio that's been labeled. And so you may have 100 million people represented in a data set with thousands of hours per user, which is a different discussion than privacy, but you have all this data, but you don't have that for Indigenous languages. What you have are the handwritten notes of a linguist from the late 1900s, early 1900s or 1800s, and you have unlabeled data that's been recorded on sometimes wax cylinder, or an analog, and there's just a huge amount of technological problems here that we're facing here. And as we're continuing this project, I'm going to kind of skip around here. I'm merging two different conversations here, two different topics here, but the things that we are facing are fundamentally this physics. We just don't have enough audio. The speakers are a increasingly rare pool. Knowledge keepers are becoming rare, and we just don't have the manpower or the resources. This is not sexy. There's no profit. It's really very difficult for a large FANG company like Facebook, Amazon, Google, Microsoft. Those guys are the FANG companies. They're not going to change Cortana or Siri or the Google Assistant for an Indigenous language because there's no profit. Like one of the languages you're working for, the Makah, and there's only about maybe 2,000 to 5,000 members of that tribe. And you're not going to make a lot of money off these languages. And so the struggles we face are just fundamental to the technology. And so what we've been working on is in that aesthetic of we want easy to use, accessible technology like HuaKi'i, and also make it accessible. And so as a computer scientist, me and the team are working together to solve that problem, which I'll touch on a little bit later. And so another aspect of this is, and like, I'm sorry, this is sort of like the thing I always talk about is that we were talking about this raw data. So you do have, so the data is rare. It's probably unannotated. It's in a mess, and it's, you know, in a state that's not very good for AI. And on top of all that, this knowledge is also sacred. So our raw data sets for working with the Wakasan languages include songs and stories that the community does not want to share necessarily. And this is a particular problem within North America, like the Lakota, my dad's tribe. We are very, the best way to say it is sexy tribe. It's very marketable. Like this is Sitting Bull's winter camp, and it's probably worth several $1,000,000, if not hundreds of thousands of dollars. And it's currently, I guess, safely sitting in the Smithsonian, out of hands, out of reach of the Lakota and also collectors. But these stories are also similar. Like the Lakota, my dad's tribe, they've had their knowledge appropriated. There's this famous author, his name is Paul Goebel, and he went into communities, knowledge gathered, you know, made friends with the tribe or the leaders, and then stole the stories and sold books and then give a single dime back. And similarly with Franz Boas, yes, we're very grateful that he documented the language and he created orthography and set the stage for future research like ours, community-based research, but he also was a thief. It was common for him to steal totem poles, religious artifacts, and sell them on the open market to help fund his lifestyle. And so this is kind of the dark side of Franz Boas' scientific work, is that he also was a thief, cultural thief, and he was also getting his research off the backs of another people. And so this raises a bunch of other, you know, concerns and questions for the tribe. And so it's very important now, move ahead to the 2010s and 2020s, what do we do? Well, what are the systems and things that we need to build that ensure that the indigenous knowledge and their heritage, their identity is being protected? And these are things that, as in our project to build ASR for Wakasan languages, at the fundamental level, we make sure that we very clearly to them say, like, we are making technology, this is our requirements, we're gonna, you know, we need audio that's annotated, and also making it clear that we don't want the audio. Our goal is not to amass a data set for profit. Our goal is to build a process and a methodology to build future ASR. So like the Wakasan are going to keep their audio. We're just going to we need to do the fundamental research that will enable ASR for other indigenous languages. And because this is critical. Like my tribe, these are the Blackfeet in Disney's Peter Pan. They literally have actually very racist, by the way. Like they have very literally black feet, and it's quite common in North America, in the world, to for Western society to take a culture, exploit it, and turn it into a commoditized product. And so it's super critical as we're building these technologies, especially AI. Like I said, like it's fundamentally very nearly incompatible with our identity. And so how do we so the question that arises then, like, why even build AI? Or is it even possible to build AI that is incompatible with your culture, to make it indigenous? And so we've been following the guideline with the 4 Rs, and there's plenty of literature out there. I won't go too deep into it. This is my wife's specialty. But it's basically just making sure that the technology and the research you're conducting is what is relevant. One of the R's is relevant to the community. Do they even want this? Do they want ASR? They want something. They did. The community that we're working wants. And also making sure that whatever we're doing gives back to the community. So as part of the process of building this data set, we've taught the community how to self-document. So they no longer have a dependence upon a researcher or an anthropologist to come in. So there's the software called Elon, and it's very complicated. It's from the Max Planck Institute, and it's super complicated and hard, and you really only ever learn to use it if you're an anthropologist. And we've gone in there and said, this is not the domain, this is not Latin, this is not the Bible of pre-Martin Luther, is that you guys should learn Elon, this technology, so you can document for yourself, and you no longer have this dependence upon an anthropologist, because the anthropologist is going to go in there and research and record audio that they think is interesting for their PhD project or maybe for their tenure track position, but you as a community might not necessarily be served. And so what we do is we teach them how to use Elon. And we also respect their wishes. So some of the data, some of the stories that we got from the Quad Youth is that they can't be, some of the stories cannot be told incomplete. For example, like this, I won't tell the exact story, but I'll give an example. What I mean by that is that there's a story where, you know, someone goes up a hill and then they walk down the hill. If the story, if you can't just tell the story about going up the hill, you have to tell the story about them going down the hill, for example. And so what does that mean in an AI context? What we've done is flagged that story, that audio, the annotated audio story, as needing to be seen by the computer in its entirety. So in the AI process, you run data into the AI and it trains it on the syntax, the grammar, and the phonemes. We make sure that that story is all self within, that's seen by the AI. You treat the AI as a visible entity that's evaluating the story. And so we're respecting their wishes in that story, because I mean, at the end of the day, we're trying to make kin with machines. And so we adhere to indigenous protocols. Our hope is that we're also imbuing the AI with a level of respect as well. And of course, relationality. We've been very clear that we're in it for the long haul. This is a long-term project. We've been working on it for nearly 2 years now. Due to COVID, we don't hang out with them as much as we want to, but we plan to, after post-COVID, spend more time. This is what me and my wife were up there. They were collecting salmon and medicinal plants on the beach. And that's the basic, the 4 R's: relationality, respect, relevance, reciprocity. And there's more. There's quite a bit of body of work out there on this stuff. I'm the engineer. If you really want to talk about it, that's my wife, of course. And why does it matter? Like, so in Denver, Colorado, there is a little museum piece. When you walk into the door, you pay your $20 American, your ticket to walk into the museum. And the first thing you see is this Tyrannosaurus Rex and like a Brontosaurus and a Stegosaurus and this huge, you know, dinosaurs. And you keep walking, and pretty soon it's a guided path. And pretty soon you start seeing mammals, and you see like saber-toothed tigers, and eventually you start seeing cavemen. And right next to the cavemen is this showcase, and it's literally my aunt's. So in the 1970s, my aunt and my mom were used as models to put together a savage or primitive scene. So immediately to the left of this little this stage of the show, these mannequins, is the caveman, and immediately to the right are settlers in a cabin. And it's like this is many layers. I think you can write a PhD on the layers of racism and anthropological bias that was built into this exhibit. So you walk from the dinosaurs, you see evolution, trilobites, et cetera, saber-toothed tigers, you know, polar bears, and eventually you start seeing cavemen, you know, primates, and then the Cheyenne, the primitive peoples, and then the gods and civilizations that's imbuing, and that's why it matters. We are not museum pieces. We are members of a living and thriving society. And so what I wanted to do is, before I move on, I wanted to real quickly pause for questions. I see there's questions in the statements in the chat. Anyone want to voice their questions?
So if people feel free to either drop a question in the chat or just jump in with voice. Well, Catherine.
Yeah, hi. Hello, Michael. Thank you for the great talk. It's such an honor to meet you. I was wondering if you could talk a little bit more about what you said earlier, that there's a very strong bias towards, you know, a male, white male's view in San Francisco. When it comes to labeling the data, and is that because it's labeled by humans, or is there also a bias in the algorithms themselves? Or yeah, could you say more about that?
Yeah, I think the bias is when you data collect. Let's take another example, just like maybe pivot a little bit. Facial recognition software. So what happens is that in these, and I don't know, I can't speak to my own company because I'm actually under NDAs, or my former company, Amazon. But prior other companies, what they do, it's very typical. Like at Google, they even did like kind of like an autopsy. What happened was that at these companies, not necessarily Google, by the way, IBM has a system like this. Microsoft has AI facial recognition. Is that they take, they have a, you always have this fundamental problem of data collection. And so a company needs to license facial pictures, right? And so Facebook doesn't share their data, obviously, not on a mass scale. And so it's very typical that in these companies that they use their employee pictures. So when you go to these companies, the very first day, you get a picture taken for your badge, and then you put like a name by it. And so what they're doing is that these companies, a real easy way to get data is just to use your employee photograph data. And so this is where the bias comes in. It's not intentional. It's not like they said, we only want this thing to work for redhead people named Ben, you know. You know, it's not Gingers and named Ben is what we're going to do. No one ever says that. It's always just like, we need data. The data scientists are data hungry. They need thousands of labeled audio or pictures. And that's what happens. And so unfortunately, these data sets start to reflect the underlying biases of the company. So you might not have very many African Americans or Black people or Hispanics or Native Americans working for your company. And so now your data set has this inborn bias toward the type of people that are employed there. And this happens a lot. And so like going back to the COCO data set, I think like it's just an issue of interest of what they wanted to collect and the interest of what they wanted to, because ultimately at the end of the day, it's a culture that labels these data, and they label these data a certain way. And that is like, it's unintentional bias. I don't think, very rarely, I'm sure someone has, but no one sits out there and goes, oh, I'm going to make this evil AI using, that's going to be biased against Black people. That doesn't happen. I'm sure someone has done that, but it's very rare. It's just sort of like you as a culture, like Catherine, if you're going to build an AI for flowers, and you're just naturally going to pick flowers that are appeasing to you. And it's just sort of like, you're imbuing the culture into the data set, and this sort of affects everything. Does that answer the question?
Yes, thank you. And would that mean if you diversify the data set, the bias would go down naturally?
Yes, and so it's actually an interesting field of research. I'm not an expert in it, but there is this growing field of research, and how do you unbias the data, and how do you even detect bias? Like a problem we have with audio is we might be recording too many of the same phonemes, for example. And so we're biasing our data toward certain sounds unintentionally. And it's really hard. It's a very difficult problem. Like it's basically how do you know that you're blind? It's a hard question, right? And so there's active research in this field. I'm not a big expert in that. I'm not kept up, but it's a tough problem. It's really hard, especially if you have cultural blinders as an English speaker, toward another language. Hopefully that answered the question.
Yeah, thank you. Very interesting.
Michael, I had a question about speech recognition and the challenges for small amounts of data there. Do you think there's a future in word finding in just sound-based systems rather than having to get a transcription, work off phoneme-based or phonetic, just straight audio processing? Is that going to be, do you think?
Oh, that's actually an amazing So yes, that's our hope. Like eventually, what we want to do is get away from this idea of needing a corpus or like orthography. Like it's, I mean, unfortunately, the methodology to what you need to do is do unsupervised learning, unannotated. What I mean by that, and so you take a bunch of audio and you try to detect the patterns in the audio. Unfortunately, current methodology requires just a ton of data. So it's typical that if you use unsupervised processes, you need a lot more data. Just because you're trying to find patterns there. Otherwise, you risk overtraining, finding things that are ephemeral or maybe noise in the data. So if so yes, I would love it if we just came in and took a small our goal, my goal would be that we can come into a community and only require 20 hours of audio to get up and started. And so I mean, I don't know, like it's not been done ever, but I imagine there may be ways to do it. It's an open question. It's greenfield science, unfortunately. It's just a problem with sparse data.
Okay, thank you. Yeah, I'm thinking a child learns 10 new words a day, and they certainly don't have, you know, hundreds of hours of training data. It's just interesting. Yeah. Our algorithms just don't seem that good.
Yeah, I'm working with a linguist. So the project I'm working with, which actually is actually a good question. Do you have any other questions? I was going to lead into my next slide set. What we're working on is let's see here. Well, so you can ask a question. I'm sorry while I'm clicking the. Yeah, and so I have been involved with, or I had the pleasure to be involved with a project that's been funded by MIT, Massachusetts Institute of Technology, and the McGovern Foundation. I keep mentioning the Waukeshan. And so this is like the people we're working with, Sarah, Child, and Maria, and a few others. And so we've assembled like a small team to focus on this technology. And it's a really good question, Janet, because like, how do we solve this fundamental problem of lack of data? And so what we're doing, so we have this problem of we want to reduce the automatic speech recognition to bare minimal. So we reduce what it recognizes. We're not going to build ASR that's general. We're not going to compete with the equivalent Waukeshan Siri, for example, or the equivalent. What we're going to do though is build a ASR that recognizes just enough to be engaging, just enough to be engaging, engaging learning experience. And so we're trying to confine what we recognize. So the more, if you reduce AI, let's see here, the performance of an AI is dependent upon what you're trying to recognize. So if you're trying to recognize 4 categories, and I'm just making this up, you may need 400 data points labeled audio. But if you want to recognize 8 categories to label it versus like 4 pictures, types of pictures versus 8, you're going to need like an exponential amount of more data, and it just continues to grow. And it's the same, similar to, this is just a general rule. This is not a hard and fast. And so for the ASR, what we're doing is trying to combine what we recognize. So it's a subset of the language, and we're defining the subset of the language based upon work by Connor Quinn. If you guys go to ICLDC, you may be which is in Hawaii, he may be familiar to you. So he's sort of divining like what is the most important things to learn about the language. He calls it MIN course, MINDOURSE course. Might be to spell that. And the our Navajo data scientist, Hassan Sosi, these are data scientists. And so they both kind of work in concert, like what is the most minimal amount of audio that we need? And so we confine to, and that's also kind of like an MVP, most minimally viable product. And so we already showed this to you. And as I mentioned before, when we're building ASR, it's a low resource, we're endangered. We're typically working with communities that have very few speakers, multiple orthographies. Like for Kwakwala, there is 4 major orthographies. There's the IPA-based one, a Napa-based one, and variations, 2 variations on both. So you have 2 Napas and 2 IPA-based ones, and you have 2 schools, UBC, and University of British Columbia, and University of Victoria, and they have their own variant on each one of those 4 sets. So you really have like 8 potential orthographies for the same language. And for the most part, luckily, since Napa and IPA are pretty similar, there's some variation, but it's not significant. But we do have quite a bit of Python scripts and normalizing the orthographies. And another issue, of course, is not English. I at NeurIPS in 2019, were you there, John? In 2019, I went to the lead ASR data scientist for a very well-known company, and he said, "Oh, why don't you just use English?" And I said, "But it's not even compatible. Like the phonemes are completely different than English." Like he just didn't get it. And what was even more worrying was that he was obviously East Indian, and he was obviously a second language English speaker. Like he should have known fundamentally that, Indian subcontinent, Indian languages are fundamentally different than English. Why would you ever suggest that? Never mind the Native American language. Like there's this completely different animals, and so that this pervasive. Every time, occasionally, when I talk to data scientists senior data scientists in the field, they just seem to think everything is a type of English. And I think I'm not a linguist. This derives from Chomsky's universal grammar work. So there seems to be this myth that all languages are somehow ultimately related. I'm not going to comment on the validity of that, but it has certainly negatively impacted the AI field, where they just assume that everything is just a type of English. You just got to tune your parameters better than you can be recognized in the language. But we don't even have the same syntax. The grammar, the structure is completely different. The phonology is completely different. It's fundamentally incompatible, and not in a way that's consistent. And one of the things, and I assume this must happen in Australia, but it's very common in North America, is from a grammar perspective or a structure of the language, nearly all languages in North America are polysynthetic, and worse, even highly polysynthetic. And I'm sorry if you already know what this means. I kind of go, it just basically means that our languages are composed of morphemes and not words. And so English is a atomic language or an isolar language. And what that means is that every word is a morpheme. The car, red car, Ben Foley has a red car. And so every word is a morpheme. And then so in indigenous languages in North America, words are composed of morphemes. And so you might have a phrase embedded, a phrase worth of knowledge embedded within a word. And so you conjugate, like for example, if this is a word that is a single word composed of multiple morphemes that says painting, expert at 1, 2, apparently she, like all these different things. Apparently she wants to be an expert at dyeing straw, which is a word in Kwakwala. And so you can embed essentially a phrase into a word. And so that poses challenges for current ASR, because they assume that you can build a statistical corpus of audio, of text. And this is where I was saying, like, I would like to get away from text as much as possible, because we have this fundamental problem of it's just not going to work. So when you build Siri, for example, or Google Assistant, they have like 50,000 rumored. I think Google has rumored has 50,000 contract employees labeling and typing up audio data and creating this huge text corpus, this statistical text corpus. And that is kind of like how fundamentally the ASR works. And you can't do that for polysynthetic language because it's potential. There is potential that a word may only ever occur once ever. Like how often do we say this? Apparently she wants to be an expert at dyeing straw. That's just a strange phrase to say. It's not something that comes up in normal conversation. And so you can't really build a statistical corpus off in polysynthetic language. You can to an extent. If you use like CRIM over in Montreal, they have built using morphemes, but they still have a fundamental problem in that they came at it with also a traditional ASR approach. Instead of words, they used morphemes, which is the next step. They went from an amazing 110% error rate to this astounding 75% error rate, which is unusual. Like basically their results were 75% of the time they came up with the wrong answer. And so I think we need to fundamentally rethink how indigenous languages are used in these statistical-based systems don't really work for our languages. And so, and then sort of like I mentioned earlier before, as part of this project, we make sure that the stories are respected. I gave the anecdote earlier about the story that has to be told end to end, and we're teaching them how to use Elong and so forth. Yeah, I think that's that. Yeah, here's some of the, so what does our data look like? We take in audio, recorded audio that's annotated. We can, I don't know if everyone's familiar with ASR. So we take the audio, this is like an Audacity or something, and then we turn it into a malgraph, which just turns this waveform into a logarithmic scale, kind of a heat map. There's a couple of different variations on that. And the ASR AI, it's looking for phonemes. We're focusing on phonemes right now. It takes this, we're using a type of image recognition as the basis of our system, automatic speech recognition. And so you kind of see how it lines up. There's like this waveform is right here, right there, like these four major waveforms that are showing up here. There's three different ways to show it. There's a lot going on here with this picture. It's kind of what's going on, what their data looks like. Yeah, so any questions? Oh yeah, Connor Quinn, yes, it's a good link.
So Michael, that issue that you talked about with the image recognition of it recognizing the wrong 80 words. If you're working on developing an ASR as a general introduction to language learning, do you find that different communities have different sets of 80 words for the language we're learning in those different contexts?
Yeah, so I think you guys shared the link. If you've not yet, I encourage you to go to here. And so maybe you can we're talking about what or actually a live version is this is what we're talking about. It's TPS. I think it's right. And so, yes. And so when we showed this in Hawaii, they were like, how come we can't get more things that are relevant, like beach? I think they didn't recognize beach and didn't recognize a lot of common things that you find in Hawaii, or like the state flower. I think a lot of the feedback we got from the Hawaiian community was, how come we can't get it to recognize more plants? They have a problem in Hawaii where we have invasive species, and they want to understand which one. I'm sorry to burp in here from soda pop. Excuse me. What they have a problem is invasive species and invasive flowers, and so they want to be able to quickly recognize through an app what's a good plant that's native to Hawaii and what's a bad flower. And so that was a big feedback from them, is that that's what they would like to do. And in Montana, when I showed this, demoed this, people wanted to know whether medicinal plants in Montana, whether, like sage, which is a type of related to the herb sage, a sacred plant in Montana. How do you recognize that? There's different species varietals of that plant. And in British Columbia, the area around here, similarly, like, can we recognize types of fish? Salmon is a staple of their society. And how do we recognize, and also differentiating different types of art? Like the Kwakwala have they have form line art, which is a very typical Northwestern art style. Their art, though similar to art in Seattle, for example, the Seahawk logo is it's very different. There's nuances, and so like there's sort of interest that can be used in visual AI to recognize the different tribes and different farmland arts. Does everyone know what I'm talking about? Like in the Northwest, there's this very typical style of arts. Let's see here. I think I'll try to find an example. Yeah, Seattle Seahawks. That's farmland art. Their logo. Let's see here. It's actually, of course, appropriated. It's like a typical farmland art, and there's different examples, much better ones than Seahawks. The Seahawks appropriated the image without permission. I think like the owner liked the look of it, and just sort of the original Seahawk is actually an eagle. It was in a museum piece. The owner saw it and said, "Let's make our Seattle logo." And I think recently, within the last 5 years, they gave the local tribes gift and asked permission to continue using the logo. But to answer your question, I'm sorry, I kind of went off on a tangent there. But I think that basically the demand is, how do we modify this in a way that everyone can that it can conform to the local needs of the people.
Yeah, it's particularly in that ASR application. So if the task is to build a minimal ASR for a language learning application, then I imagine that the words that you choose are going to be different for each community. But have you gotten to the point of seeing how different those applications would be for different communities?
So it's a better question for my wife, honestly. She's the polyglot. She's also getting the linguist degree. But I would say that, so what our process is that working with Connor Quinn, he has worked for decades to awaken languages that have fallen asleep. And as part of that process, he's identified when you go into a language that has fallen asleep and you're trying to reawaken it, you have to deeply think, what are the most important bits of that language to bootstrap the next generation of speakers? Because you may not have heard, there might not be audio, or there may not even be anyone who, like, there may not be much documentation, or there may not be all these different negative effects. And so if a language is sleeping, then you don't have speakers. And so the very first step is you need to create more speakers as quickly as possible. And so he created this kind of methodology he calls mid-course. And I've told him he should come up with a better or sexier name because he's American. But it always is better in America to have a sexier name or more intriguing name. And he has developed this methodology over decades of like going in and determining grammatical structures and concepts and words that are important to the language in concert with the community. And so he doesn't know the culture, he doesn't know the words or animals that are necessarily culturally significant, but he is a linguist and he's like a structuralist linguist. He's able to kind of say, okay, these structures are kind of exotic, these phonemes are hard for an English speaker to teach, so we should focus on teaching these syntax structures and phonetic structures. And then he turns to the community and says, what is the content that goes along this linguistically important married with the culturally important? He works with the community to do that. And so when we're working with the two tribes that we are currently working with, they are linguistically somewhat similar. They do share borrow words. They do have similar grammatical structures, but that min-course is radically different for each one of them, even though they're related culturally. Like one's in Washington State, and they can literally see their brethren across the strait, separated by the Canadian border, but they have very different values and cultural requirements. And so it's definitely a culture, a culture by culture. It may even be village by village what this looks like when we're building this. So there's not going to be a catch-all, honestly, when you're building these data sets.
Thank you.
That's a very long answer. I'm sorry.
That's a, yeah.
Yeah.
That's good.
And talking about bias, like I think we just sort of accept the fact that there's going to be bias, but we might as well make it culturally biased for the people we're building it with. And that's sort of our response to we're always going to build something biased. I think trying to avoid bias is going to be very difficult. And given our work, why not we just make the bias, knowingly make the bias toward the people we're working with specifically.
And making these much more targeted applications of the language technologies rather than the previous years people thinking, oh, we need to build ASR, so it's got to be a global general system to suit every purpose, but maybe it's more appropriate to develop very specific things for particular purposes with the community. So
yeah,
there's maybe more control over it, and accuracy is better in that situation too.
oh, absolutely. That's totally a concern that we have when working with the communities, because they don't want. So some of our allies, you might know them, the Tahiku Media there in New Zealand, closer to you guys they are to me physically, but I work with them. They're our mentors. They've built ASR for Maori, and they are definitely very concerned because there's not more than just one type of Maori. It's a whole, ecology of thought and different languages, and they're very worried that a standard Maori was going to take over, which is, I mean, certainly is better than no Maori, but it's also in a way it's on colonization. And so it's really important that when you build these ASR that you're not trying to unintentionally normalize the culture. Like our goal is definitely not to avoid the one true Wakashan, that we're just doing the same thing over again if we do that. So absolutely, Ben, like everything we're doing is assuming that we're trying to build the most customized version of the language for the people that speak it. Yeah, so anyway, so if you don't have any questions, if you visit this huakii.indigenous.ai.dev on your phone, I'll turn off my background. Turn it off so you can see my phone. So if you go on your phone, like I encourage you to do it now. And you're going to see this, and it's sort of loading. And so the cool thing about this is what we built. So it's going to ask you for your camera. And the cool thing is that this is entirely on your device. So nothing gets uploaded. It uses the Cocoa data set, kind of like it's basically a mobile model. And everything happens on the device. So I would suggest not running it. It would actually drain your battery. I mean, I don't just running it for hours at a time, or if your battery is below 10%, it will kill your phone. But I'm particularly proud of the fact that what we built is not, cloud-based. And so this will work offline. Let's see if I can't seem to click my own button. Oh, there we go. Yeah, and so you can kind of see the recognition happens when you look. I encourage you to look around. Sorry, I think I'm having like a CSS problem. Click it. There we go. And so we go around, and then we didn't do all 80 because we didn't have a word in Hawaiian for ski, but we did do 70-ish words. And if you're looking at this website, what you can do is you have the GitHub link. And let's see here. Come on. You can see the GitHub link. If you click on the GitHub link, it takes you to the GitHub page. And when you go there, if you kind of go, there's like this easy option, the easy remix. If you click that, the Huakii glitch version, what it'll do is it'll pull up the same website, give it permissions. And what you've done is actually created just now. What you can do is that if you look at it, if you click on the remix button, it's got the little fish on it. What that does is creates a whole new private version of the Huakii app. And so right now it's populating it. And so it's deploying in some cloud container on Glitch's website a version of this app. And so what you can do when you're on there is that if you look in there, you can kind of see that it gives you the source code. Is what you can do is there's a little button on the far left. It's like a little arrow, and it kind of will show you this. And in there, you can see a dictionary.json. So if you click on the dictionary.json, and then you see the words. And then let's see here, kind of the camera's kind of getting blown out. And so you can go in there and actually change it. You can go in there and live edit. So I'm going to change this person to Kanaka, which means person in Hawaii, and I can change it to Michael. So I've changed the Huakii, or the dictionary for person. I've now made Michael. And then what you do is there's a little sunglass icon at the very top. Click that and do in a new window. And then now you can get like a weird URL, like this one's like Walter something something. Press allow. And now if I recognize myself, let's see if I can do this, coordinate myself better. It's Michael. So you can do this live within a few minutes. And that's like the best feature of this, is that anyone can take this and create their own version of it within a few minutes on their phone. And I think like that's the kind of technology I want to do. And that's also how I want ASR to be. Like, it's obviously never going to be as easy as that, but I would love it to be that the next version of this, the more complicated version of Huakii, is that it recognizes audio. It recognizes images, and it does so in a way with as minimal amount of engineering help is required. Like, you just click buttons, you upload the audio. Like, my vision is that if you go into a community, be it in Queensland, and we go to the someone that works on the Makurtu project, or someone in the deep inland of Australia, and say, we just need 20 hours of annotated audio. Give us your most important 80 words, and then we upload it to some website, and then they come back out. We get a Huakii version for your language that recognizes your audio and then recognizes the world. And this is sort of like a point and click operation. And that's my vision. And it's private. It works on your phone. Interior Australia, I assume, is very similar to Montana. There's not very many Wi-Fi points, and so some of these things need to be like designed from that perspective. And as an engineer, that's what I want to work on. Is the hard problem of making this hard stuff easy. That's where kind of I see myself and my life goal where I'm at.
There was a question earlier about the labeling of the object recognition data being human or machine labeled. So it looks like Coco is largely machine generated labels.
It's yes, yeah. I think it's a combination. I think the original data set is human. Coco's old. I think it's from like early. I'm not sure exactly, but I think humans labeled the data and then they use that for the object recognition.
Do you think it would be a major task to develop a interface for people to take control or to have ownership over labeling of objects that are culturally more relevant to them than, so if we wanted to recognize a local fire hydrant here?
I think it's really, yes. I think there's technologies you can build to make it easy to label, but ultimately the difficulty will always be you're going to have to label every single someone has to manually type, and even if you start copy pasting, that's an optimization, but it's still kind of, at the end of the day, there's always going to have to be some human interaction. And that's sort of the deep dark secret of AI, is that there's a lot of underpaid people out there just slapping the keyboard all day, labeling audio. It's like it's the artificial intelligence, the exciting and cool part that's done by engineers. That's barely the tip of the iceberg. The rest of it is this massive effort of human engineering that's required to label the data. Like, it's really hard. Like, someone has to label the millions of hours of Siri raw data. It's hard. That's the real, like, it's very typical. The general rule in AI is 80% of your effort is going to be labeling data collection. And so until we have general AI, which if it ever happens, a type of Skynet, it's always going to be the fundamental barrier to AI. Someone has to label the data. And Americans, and then Australians too, hide this by offshoring it to India or Vietnam, or the typical East Asian countries who don't have very good labor practices, unfortunately.
Michael, I had a question about the way in which the fundamental data is managed. So under the hood, when you've got a lot of speech data, is there a way you think about setting up the data manager in a way that is accessible to people in community, easy to use? I know you talked a little bit about teaching people to use Elan, which is good if they wish to do that. How do you set up the data in ways that people can record, store, back up in an easy to use way?
Yeah, so what we're doing is, are you familiar with Dr. Stephen Bird's work down there in Australia? Actually, a lot of our stuff is influenced by you all's work, honestly. He built like an Android app years ago when I first met him, Dr. Bird, and he went out into the bush, as he said, and collected audio on an Android app. And then when you get back to Wi-Fi, it uploads it to Google Drive or something. We're doing something similar. We use Dropbox, and we're using, to make it more generalized, we're using different technology that works on both Android and iPhone. Like, that was like a big problem with Dr. Bird's early app. I'm sure he fixed it right now, was that it only worked on Android. And so our goal is to make the technology pretty seamless. But it's basically just, we're building like most of the engineering effort, honestly, is building infrastructure to collect audio, make it as simple as possible. Like, basically click, say a word or a phrase, I'm going to stop recording. Anyways, Hunter. You have a question?
I think Hunter had a question.
You're unmuted, but I don't hear anything.
Hunter, did you have a question?
Maybe you can type it out. Might be having a tech problem. No. Why? Here, I think he's in a question there. Yes, and so I think I'll answer your last question. I think allies play an important role in my goals, in every Indigenous people's goals. Like, before, and the reason why I say that is that this concept of being Indigenous pre-contact had nothing to do with your genetic background and everything to do with your cultural willingness to integrate. Like, for the Lakota, it was a nation state, and there were citizens of the Lakota nation, and they were not all some monolithic genetic, like, we weren't like this pristine Lakota genes, It's just, it was a nation state composed of people who were different ethnic backgrounds, just similar to Australia and North America. And so it is traditional that if it was so if Ben wanted to and put in the energy and effort, he could be a Lakota person, or same thing with Jeanette. So I think when you say non-Indigenous, I think everyone could be Indigenous. Everyone is Indigenous. So Indigenous just means literally person of the land, And so there's this artificial construct of identity within indigenous peoples that's been imposed upon us by colonialism, that we have to adhere to some idea of purity, is a hard concept to get over with. And so I guess the short answer is yes. I think non-indigenous people are more than welcome to assist, as long as they're willing to operate within the cultural norms of the society you're working with and come from a very pure perspective, and that you're not trying to exploit them, and being very clear. It's not, and so like allyship is that, it's no different to be an indigenous tribe than it is to get a passport for the United States. You go through this process of citizenship, and so similarly the tribes have that as well. But as far as their other question, yeah, I mean, I think that's basically a very standard use case for educational software. Anyways, Aditi.
Hi, thanks for the great talk. I had a question about the dictionary thing which you showed in your app right now. So it appeared to me that there were one-on-one translations, like for person, there was a word in the target language. So how, like what about the cases where you might have multiple translations, like not synonymous, but they might be very similar, like maybe cooked rice has one word, or like different varieties of rice may have different words. So how would that be featured into the same setting?
It's not. That's like what you're identifying is this functional incompatibility. I think it's just, that's the problem. What happens, what the AI does is basically you put in an image and it spits out a number between 0 and 80, and then it corresponds to a category. And so what it's doing is categorizing images into one of 80 possibilities or nothing. Like you don't know what it is. So I guess 81 options. And so you would need a visual identifier that also understands context.
Right.
So like what you just said, and which is technically very difficult. I think we just barely get in there. Like I know Google has some AI where it can tell you that the man is holding a brown phone, et cetera, that kind of like, and it's in front of him, his face, right? And so like that's kind of, it's an order of magnitude more difficult. This is the goal was to make it as easy to replicate, which also made some engineering sacrifices, and it's very stupid. It's always a balance as an engineer. Like you can make it easy to use, but that means it's going to be not as good. It's yeah. So that was a conscious design decision not to care about those kind of nuances.
Okay, got it. Thank you.
Yeah.
Maybe a follow-up to that, Aditi, do you have your the paper that you showed me recently with
Yes.
the Spanish? Could you screen share? And
so
okay.
basically, we were working on an application where we look at how can we teach vocabulary which exhibit fine-grained lexical distinctions, like the one I just was talking about. That let's say we are learning, like somebody's learning Spanish from English, and often there is not one-on-one mapping between the words. Like the an example that we looked into was that like wall. Yeah. Thank you, Ben. So different languages carve up the space differently. So the seemingly same concept wall, it comprises of many different kinds of walls in it. But in Spanish, there is like a fine-grained distinction between that concept. So if the walls are indoors, then it's called pared. But if the walls are outdoors, like a city wall or a garden wall, then it's called muro. So if somebody wants to learn Spanish, then they also need to be aware of these fine-grained distinctions which arise across different language spaces. So seemingly like words which have one-on-one mapping might be easier to learn, but for such fine-grained distinctions, if somebody were to teach it to them, like maybe through some definitions or rules, then the learners might be able to learn them more effectively. So in this work, we basically study how we can extract or identify these lexical distinctions automatically, and also how we can extract like some concise rules with which we can teach learners these new vocabulary words. This was done on high resource languages, Spanish and Greek, but now I'm interested to actually apply these methods on languages which lack sufficient learning resources and where it might actually be of use.
How are they being labeled? Like, are they labeled in Spanish?
So these right now we have considered like one-on-one translations, and we basically automatically identified them from available parallel corpora. So we took available English to Spanish movie subtitles, and we applied some sort of NLP methods to automatically identify such pairs. That, okay, this particular word in English has multiple translations.
So I guess it's
Awesome. That's
comes
cool.
down to a labeling problem again.
It's always a labeling. I mean, every AI problem is a labeling problem, I think.
Yeah.
At the end of the day. Well, I mean, it has a significant component of the research. I mean, like I know there's like, so this is like a AI, a neural net you've built or something? Are you working on?
Me?
Yeah.
Oh,
Like how,
So in this method, we basically used very simple classifiers because we wanted them to be interpretable. And your typical neural networks are not interpretable because we also wanted to extract rules like when do you decide which translation to use, under what context. So for that, we used like very simple linear classifiers, which basically assign weights, and we can easily extract human readable rules from those.
awesome. That's kind of cool. Yeah, I mean, that's pretty cool. No, I think like we're the Huaki is like nowhere near that. It's basically just a really dumb technology compared to that. Yeah, I mean, there's just, I mean, if you acknowledge the fact that it's the types of limitations you want, it's
Yeah, no, but
Yeah,
even
that's-
like whatever like methods we applied, the caveat is that we have shown them on 2 languages which have at least mid to high resources, but the kind of languages we want to target, like the ones we talked about, they have like really low resources. So the real challenge is then how can we also apply it to the real world setting and also like make it more, as you said, more usable, also like cheap and use it. So it's like, how can we marry both these approaches together?
Yeah, what we're doing is we're using finite state transducers to document the grammar. It's a very common thing. It's nothing new. It's like stuff from the from the 60s and 70s. This FSTs. For everyone who doesn't know, it's just basically like a grammar definition. Computer languages all have some sort of finite state transducer, like C or Python. They all have like if there's some FST back there running the interpretation of the language, and that's how that helps try to get rid of the corpora dependency. And that's like one approach you could use as well, like maybe to try to minimize the data.
Yeah.
An FST is essentially just making a hand rule. It's basically a rule. Yeah. So I'm kind of wondering, it's sort of like it's a very ambiguous question of like, how do you know what side of the wall you are on? Like, suppose you're looking like, it's just kind of the AI has to kind of guess then, right? It's like if you're in a courtyard, you're looking at the wall. How do you know that you're on the inside? You just have to. Hopefully, the picture contains a corner that's inward facing. I guess.
Yeah, or maybe like if it's like at least some portion of the sky is visible and possibly it's outside. But if something, or I don't know, like if there are paintings hanging on a wall, then probably it's inside a house. So
okay. Yeah. No, I'm sorry. I didn't mean to interrupt you.
No, I was done.
No, okay. I think I totally misunderstood. You meant like you talk about a wall inside a house differently than a wall that's in the outside in the corner. Yeah, okay. Versus which side of the wall are you on?
Oh,
This is
no,
the
no, no,
ambiguity
no.
of English.
Sorry, no, yeah, I meant like wall inside and like a wall which is outside the outside the house or something like that. Yeah.
No, but I mean, which raises another good point is that English is really ambiguous. Like, what do you mean exactly when you say, like, I almost like in a way, like ASR for English or language technology for English is probably the hardest because it's so irregular and ambiguous. So my wife speaks German and French. She grew up in Germany and Spanish, and they have a lot more pronouns and a lot more precision in the way things are constructed. And so, like, she's always throwing a pronoun at me. I'm like, I have no clue what you're talking about. Like, it's like a constant point of contention. Like, I don't know what you're talking about. Can you explain? Yeah, that's the problem of English. Anyway, we got like 5 more minutes. Any other questions out there?
So Hunter, do you want to jump in with your question?
Okay, I got it all working. So my initial thought was that your plant identifier to determine whether it was native versus non-native could be utilized for maybe tourism to help people who come over identify plants, which might be an interesting use case that you could get funding from, say, the tourism for Hawaii or someone else. The question then followed on was, how do you approach like the purity of your idea, which is serving an indigenous community versus compromising a little bit to acquire funding versus, that's what I meant by the non-indigenous people, which is, do you bring other people in who can provide funding or even knowledge, but then maybe they change the vision for the project and how you approach that?
I'm sure you can talk to Janet and Ben, but this is basically the fundamental problem of academic research. You have to justify what you're doing to someone who has the money. And unfortunately, indigenous peoples very rarely have a lot of money at their disposal. And so, I mean, so when we got this grant from MIT and the McGovern Foundation, we were very lucky in that there were very few strings attached. We just had to make the promise that we had to make was that they had impact upon the community, and that was easy. Like, of course, we were helping them document their languages. That's the impact right there. Like we can, and so there's always going to be kind of a balance between what is the funded sources and your what your goals are. And I think it's a hard problem. Like I can't say I have there's no tried and true. It's just honestly, I'm sure, talk to your instructors, but they have experience with grants, I'm sure. It's always a battle between what you're trying to do and who's willing to fund it. In the States, it's worse than Australia, mostly because there's very little governmental funding for pure science. Unless you're building a bomb or helping build a wall, like it's very difficult to get research funded in the States. So for non-military work.
So Janet has to go to get ready for her next lecture. We could probably call it a day here too.
Yeah.
So
can I just, before you do, Ben, can I just add one comment? Michael, thank you so much for the presentation. It was very engaging and was awesome. But I just wanted to make a comment to Hunter in relation to Aboriginal languages in Australia. I'm not sure whether your question was about Indigenous languages to Michael's Indigenous languages or internationally. But here in Australia, there is a very clear requirement that the outcomes must benefit the community and that they must be determined by the community. So, and that's a requirement by AATSIS and all of the ethics standards, including NHMRC. So if you look seeking funding for a purpose that is in contradiction or to compromise what the community are asking, then you need to go back to the drawing board. I hope that helps. Thanks.
That's awesome. We don't have, there is some regulations toward that effect, but nothing as stringent as that. I think the American version is that if you're working with a recognized indigenous tribe, they have to say yes. They don't even necessarily even have to, but your rule seems to be that not only they have to say yes, they also have to benefit. There's a lot of, that's just fine nuance, but actually it's significant. That's pretty cool. I did not know that Australia had that.
Yeah, and it's actually, I'm not saying that everybody complies with it, but that's if you want to do ethical research, and ethical research with Aboriginal peoples in Australia requires that you follow AACCIS guidelines for ethical research with Aboriginal peoples in Australia. So most people haven't in the past and continue, a lot of people continue not to, but it's not seen by Aboriginal people then as ethical research. So it's not considered in the eyes of Aboriginal people as valid. If it doesn't follow those guidelines.
Okay, well, thank you for that. And thank you for inviting me. Maybe one day I'll see you guys in person when this is all over one day, hopefully soon.
Fabulous. Thanks, Michael.
Thanks, Michael.
Thanks, everybody, for joining us.
Thanks.
Thanks, Ben. Janet.